All right, 8th grade, this video is going to be video 4 of lesson 8.6, and it's going to be the second video dealing with word problems. This type of word problem in this video is going to deal with the formula distance equals rate times time. Okay, now you may or may not have used that in a science class previously, but this is a common formula used in many applications for math and science. Distance equals rate times time. Now there's other ways you can write this formula depending on what you know and what you're trying to solve. Time could be equal to distance divided by the rate if you divide both sides by r. Your rate can be equal to the distance divided by time if you divide by t. So depending on what you know and what you're trying to find out, you can write this formula in different forms. Now the reason why we started with this formula is when you set up your fractions and your rational equations, this is going to help you organize, well, what's going in the numerator, what's going in the denominator, what goes on the left, what goes on the right. And so that's what this all is up here. So in the last video, I told you to ignore it. So here we have distance equals rate times time. Here is if we solved it for time, and here is if we solved it for rate. Okay, so let's dive into guided practice 4. The speed of the wind is 20 miles per hour. It takes a plane 7 hours to fly 2,368 miles round trip. What is the plane speed in still air? So this is going to be a distance, rate, and time type of equation because it gives us a distance of, here we go, mileage. It gives us our rate, and we're, it gives us our time. Now, it tells us a rate with the wind. We don't know how fast the plane would go with and without the wind. So when we're setting this up, we want to get all of our pieces of information organized. First of all, it gave us the mileage round trip, which means we have to divide that in two to see how far we went to and from our destination. So 1,184 miles per direction. Another piece that we need to keep in mind is that one direction you're traveling with the wind and the other you're traveling against the wind. Now don't start thinking, well, what if the wind direction changes? Because then I can no longer help you. So we're going to not do what ifs in these problems. Okay, so now we organize that information. Well, the time with the wind plus the time against the wind is going to give us our total time. So we know the time, essentially. And we're going to use this formula here, time equals distance divided by the rate, to help us make sure we set up our fractions appropriately. So time with the wind is our distance divided by the rate, plus the time against the wind, distance divided by the rate, equals our total time of 7 hours. There, back, total. So the distance on the top, that's why we divided it by 2, there and back. Our rate, it's the plane's speed plus the 20 miles per hour and the plane's speed minus the 20 miles per hour. And now, once that part's set up, now we just solve like we did back in video 2. So I'm not going to spend the time really going through that in too much detail because I want to focus more on the word problems in these videos. Okay, but this is the work for it. Find your least common denominator. Clear your fractions, just like we did in video 2, by multiplying each fraction by the least common denominator. Cross off what they have in common to set up your linear approach. And then solve. So quite a bit of distributive property happening here. Distribute, distribute. We've got foiling and distributing. So this one is a little bit lengthier, but don't worry, the next one is a lot shorter. So this is going to be the lengthiest problem that you'll see. So just FOIL, we come down to a perfect square trinomial. Distribute your 7. On this side, we combined like terms, and notice we had some values crossing off, which is nice. And what you might be noticing is we have a p squared left here, so now we have a quadratic. All right, so go ahead and write that in standard form. Use the quadratic formula. Of the two answers you get, one will not make sense. Obviously, this one, negative 1.18 miles per hour, would not make sense. So keep at least, I only kept 1 here, but you probably should have kept 2. That's okay. Keep at least 1 decimal point in your final answer. Okay, and that, like I said, those are going to be the lengthiest ones. Anytime you're dealing with rate with or without wind, or with or without a current of a river flow, anytime you have something working with you and working against you, it's going to take a couple extra steps to solve, but we've been doing this since 7th grade, so you got this. And I'm going to go ahead and stop this video as well so that you can take this in steps, and when you're ready, we'll move on to the final type of example.